In this video, we will discuss insertion sort. Sorting is a technique to arrange the elements of the items in particular order, either in ascending or descending order. In this sorting technique, that is insertion sort, we sort a set of values by inserting values into an existing sorted file. As we are seeing in this card examples 2, 4, 5, and we have to insert this card which is having the value 7 in between 5 and 10. So the name that indicates that is insertion means we have to insert the values in between two already sorted elements. Okay, so this technique is same as we used in playing card when we choose first card that is already at the right position, and for the second card we compare it with first card if the new card is lesser. Then place it in the left side, otherwise place it in the right side. Similarly, choose next card, then place it at the right position in already sorted cards. Clear? So repeat this process to sort the whole cards. It's a very simple insertion sort techniques we are using from our childhood. So the time complexity of insertion sort depends on comparisons and movement of the elements. So we'll discuss in detail. Suppose I have taken 5 cards having value 10, 7, 8, 6 and 9. Parallelly, I have taken the same element values into the array, and this is the algorithm of insertion sort, in which we are passing simply the array, the base address of the array. The length of the array is stored in the variable that is L of integer type. For j is equal to 2 to length of a, that is L, and then j plus, we are using this for loop. So this will indicate our passes. Clear? Key is aj, means we are just storing j is equal to 2. The value is stored at jth position, j is equal to 2 position, that is 7, into the variable key. So I am taking in the green box the key value 7. Clear? Now I am finding the value of I, that is j minus 1. So j is 2, 2 minus 1, that is 1. Clear? So I am indicating I here, j here. Now I have to compare. First I have to check whether I is greater than 0 or not. I am taking this test due to the condition whether we are crossing the limit of the array or not. Once we cross it, it means we have to stop. And second thing is, we are taking two conditions in while loop. Second condition is ai is greater than k. If ai means, suppose I is 1, that is 10, and then comparing with the key value, that is 7. If ai is greater than 7, it means we have to shift this 10 to the right side. Clear? Otherwise not. So we are just shifting the value of 10 to the second position, and the resulting value will be this. So we have overwritten the value of 10 at the second position. Don't worry, our key value is already stored in the key value, that is key variable, that is 7. So there is no loss of data. Now again decrease I by 1, that is 0. It crosses the limit. So stop here. Now come to the outside of the while loop. Then I plus 1, 0 plus 1. Now store, or you can say overwrite the value of key in the first location, like this. Now you can see the two elements are sorted now. Here we can see our two cards are sorted now, which are in the left hand. Now the second card will choose, that is 8. Now we can see practically the 8 should be placed in between 7 and 10. So now applying the algorithm again, now j is at 3. Clear? Because loop is incremented by 1. Now the key value is aj, that is a3, that is 8. Now the key value is 8. I is j minus 1, that is 3 minus 1. Now I is 2. 2 is greater than 0, okay, and a2 is greater than key. a2, that is 10, is greater than 8. Yes. So we have to shift 10 from this place to this place. Okay. Reduce I by 1. Now I becomes 1. 2 minus 1, that is 1. Clear? Key value is 8. But should we terminate the while loop? No. Because 1 is greater than 0, condition is true. And AI is what? AI is A1, that is 7. 7 is greater than 8. No. If one of these two conditions is false, then we have to terminate. Okay. So this condition was true, but now our second condition fails. So we have to terminate the while loop and come here. Now the I value is 1. A1 plus 1, A2. Now overwrite the key value, that is 8, to the second position of the array. Clear? Now you can see our 3 cards are sorted, which are in our left hand. Now pick the next card, that is 6. Similarly, apply the algorithm, and we know 6 should be placed before 7. Clear? So how it will work? Now j is 4. That is first pass, second pass, third pass. Clear? So j is 4. Key value is aj, that is 6. Key value is 6. I is j minus 1. 4 minus 1, that is 3. Now 3 is greater than 0. Yes. And a3 is 10, is greater than key, that is 6. Yes. Then shift this value 10, ai plus 1 is equal to ai, means the value which is located at where index number 3 should be placed to location number 4. Then reduce I by 1. Now you can see we have overwritten the value of 10 in cell number 4 and reduce the value of I. Now I is 2. Again repeat this loop. 2 is greater than 0. Yes. And a2, that is 8, which is greater than key, that is 6. Yes. Again shift the value of this to third place. Clear? And reduce I by 1. So I will become 1 and that will be overwritten. 8 will be overwritten on third position. The result will be this. Clear? Now I is 1, I is greater than 0. Okay, condition is true. And a1 7 again is greater than key value is 6. Both conditions are true. Then shift 7 from first location to second location. So ai, that is 7, is overwritten on a2. So 7 will shift to this place. Clear? Now I is reduced to 1 again. Now I is 0. So condition is fail. So we will terminate the while loop. Come outside to the while loop. A 0 plus 1, that is 1. Clear? Now write key value, that is 6, to first location. Okay. So now you can see these cards are already sorted, but only one card is there which is not sorted. Clear? Pick this card again. Now we know the location of that card is in between 8 and 10. So now we will execute this algorithm and see how it is working. Clear? Now j is at 5 position. I is j minus 1, that is 4. Key value is 9. Now simply execute this while loop. I, that is 4, is greater than 0. Yes. And a4, that is 10, is greater than key. Yes. Now shift this 10 to location 4 to 5th location. Clear? So we have overwritten the value here. Now I reduce to 1. Now I is 3. So I3 is greater than 0. Condition is true. And A3 is greater than key. A3 is 8. Is greater than 9. No. Condition fails. Come outside. A4. 3 plus 1. A4. A4. Now write the value of key is 9 on this location. I think now everyone can understand this concept, how the insertion sort works. So finally we got the sorted array. So here we can see the cards which we are playing from our childhood, how we are sorting. It's a technique which is known as insertion sort. Now we can see in a fast way, this was the input and this was the first pass, and in the left side we are seeing the already sorted array, and the next item comes. So we apply, just like linear search, we look the position where that value can be fit. So here we can see the 8 is placed in between 7 and 10 in second pass. In third pass 6 is placed at this position, and finally in the fourth pass we can simply sort the whole array. Now see, number of passes are n minus 1. Total number of elements were 1, 2, 3, 4, 5. So now total number of passes are n, and it is 5 minus 1, that is 4. In 4 passes we have sorted the array. Now come to the time complexity of insertion sort. Here we can see worst case and best case. We will discuss these two cases. In worst case time complexity, we look the maximum time taken by the algorithm. Here we can see the worst case is if the array is reverse sorted, just opposite. So we have to do the maximum effort to sort the array. So here 10, 9, 8, 7, 6. These are reverse sorted, and we have to take this value 6, 7, 8, 9 and 10. So we require this value. Clear? So now see in first pass what we have to do. We have to compare this value with this. Comparison is 1. And shifting is, we are shifting 10 here and then overwriting. Shifting is 1 only. One move is required, one comparison is required. Total 1 plus 1, that can be written as 2 into 1. In second pass we can see now the 8 is compared with this value and this value. 2 comparisons are required, and shifting, shift 10 here, then 9 here, then place the value of 8 here. So total moves are 2. 2 plus 2, that can be written as 2 into 2. Now come to the next pass, that is 7. 7 have to be placed. So because this is reverse sorted and we are taking the case of worst case time complexity, so maximum efforts are required in this sorting example. So 3 comparisons and 3 passes, and finally the last value, that is 6, we have to place at the first position. Then we require 4 comparisons and 4 moves. Total 4 plus 4, that is 2 into 4. Clear? Now see, if we add these total comparisons and moves taken by the example, then generalize it and find the time complexity of insertion sort in worst case. So Tn, that is a time complexity representation of time complexity, that is Tn. 2 into 1 plus 2 plus 2, 2 into 2 plus 2 into 3 plus 2 into 4 plus, if we generalize it, so number of suppose n elements are there, then we require number of passes, that is n minus 1. So we will take up to n minus 1 for general term. Then just take common 2 and 1 plus 2 plus 2. This is simple addition of general numbers, a 1 plus 2. This is a series. Okay, so we can apply the summation formula, 2 into n plus 1 by 2. So n is n minus 1, n plus 1, so n minus 1 plus 1, that will be n divided by 2. 2 is cancelled out by 2, so n into n minus 1. So finally the leading term will be O of n square. Clear? So this is the time complexity of insertion sort in case of worst case. Then if we see the given array is already sorted, this is the best case time complexity, that is 6, 7, 8, 9, 10. In first case we have to compare, but there is no need to shift. 1, then 0. In second pass we will compare the value, but there is no requirement of shifting or the moves. Then we have to compare, but there is no need to shift. compare, no need to shift. Clear? So then total, sum it, and 1 plus 1 plus 1 plus up to n minus 1. The total sum will be Tn will be n minus 1, and finally Tn is omega of n. So this is the time complexity of insertion sort. In best case it is omega of n, in worst case it is O of n square. So if we see the space complexity of insertion sort, then we will see the total algorithm is taking a space that is nothing. It is just like it just uses the variables L, J and I. So it is a in place sorting because it is using the space already taken by the function, that is main. So it is sorting the whole array in the already used space. So only it is taking L, J and I. So it is not require more memory to sort the array. It is using the already used space by the array. So no other memory is required. So it is an in place sorting. If we see, because the time complexity in best case and worst case are different, so we have already discussed the category. If any algorithm is taking different time complexity in any of two cases, then that algorithm comes in the category of adaptable. So this algorithm is adaptive. It is in place, it is adaptive. Or I'm giving you one assignment. Suppose if two duplicate values are there in the array, then how the insertion sort works, whether it replaces the values or it keeps the sequence after sorting the both of the elements same. So if the two duplicate values are there in the given array, and if the algorithm places the two duplicate values in different place, or you can say change the sequence, then which type of algorithm is? This is the assignment or is this the question? Clear? I think all of you can understand it. It is stable. I'm asking about stability of the algorithm. The algorithm is stable or unstable. So we have to check, this is the assignment, whether the insertion sort is stable or unstable. Okay, thank you. Now we'll see you in the next video. Implement the insertion sort in C and try it at your own. Thank you.